Hello everyone and welcome. We're going to be looking at our 8.2 Pear Deck, kind of our last big lesson together, which is wild. So you can put your name on that first slide. We have 13 slides in total, and we're going to be looking at solving quadratic functions. So we spent a lot of time factoring in Module 7. Last week we started looking at what is a quadratic function, what does that graph look like? And now we're going to start putting the two of them together. So if you push ahead to slide 2, it says squares and square roots. So I know we were looking at these a lot when we were factoring with our factoring patterns, but we just want to recall the difference between squares and square roots. So when you square a quantity, you are multiplying it, multiply the quantity by itself. So when you're looking at squaring 4, 4 squared is 4 times 4, which gets us 16. Okay? Negative 3 squared is negative 3 times negative 3, which gets us a positive 9. 0.6 squared is 0.6 times 0.6, which gets us 0.36. 3/4 squared is 3/4 times 3/4. Now, when you multiply fractions, you multiply across. So 3 times 3 gets us 9, and 4 times 4 is 16. So that's all squaring, where you take the number, you just multiply it by itself. The number 2 is telling us you're multiplying it by itself twice, so there's 2 of them. When you're taking the square root, you're doing the opposite. So for this, we're saying what number multiplied by itself gets us 36? And that number is 6. 6 times 6 is 36. Now to get that x squared, we have to do x. And we can check this, right, just to show you. What we're doing here is we're saying 6x times 6x is 36x squared. So the square root of 36x squared is just 6x. We can put a plus or minus, because it could be negative 6 times negative 6x to get us that positive 36. So now that we're starting to take square roots, we want to think about putting that plus or minus in front of all of our solutions. So for the next one, for the square root of 25, this is plus or minus 5. And the reason, again, just to show you, right, 5 times 5 is 25. But also negative 5 times negative 5 is 25. So it could be a positive 5 or it could be a negative 5. For this next one, we see a negative under the square root. So this is an example of no solution since there is a negative under the square root. As of right now, this is no real solutions. You will learn later in your algebra career what we can do in Algebra 2 in a couple years. But for right now, no solution. Square root of 50. 50 is not a perfect square. We can simplify it by splitting this up into the square root of 25 times the square root of 2. This is something we did way early in the year. 25 times 2 gets us 50. The square root of 25 is 5, and then we have root 2. And we could just put that plus or minus in the front. So if I were to go in my calculator, because 50 is not a perfect square, we're going to get this big decimal. Notice if I also do 5 times the square root of 2, we'll get the same thing, right? Or negative 5 times the square root of 2. We'll get the same. That should not be right. 5 times the square root of 2. So Beautiful. That's as simplified as we're going to go for now. So I'll just leave this as positive 5 because it's not a quick evaluation. Beautiful. Okay, let's go ahead and look at slide 3. So solving a quadratic equation means that you are finding the x-intercepts. So when you think of a graph, we have our x-axis and our y-axis. When we draw some quadratic function, we are going to see that what we're solving for are these x-intercepts. We're looking for where it crosses the x-axis. We also refer to these as roots or zeros. The x, and this is the x value when the function equals 0. There are many ways to solve quadratic equations. We are going to start by using the square root method and the factoring method. Those are the two methods we're going to focus on in this lesson, okay? So as we solve these quadratic equations, as we continue, we are solving for the x-intercepts. That's what we're finding. So let's look at slide 4. First, we're going to look at the square root method. So here we have x squared equals 25. So whenever we see a squared, the opposite of squaring is taking the square root. So we could take the square root of both sides. The square root of x squared is just x, and the square root of 25 is plus or minus 5. Right? 5 times 5 is 25, or negative 5 times negative 5 is 25. So let's show you what that looks like in the Desmos graph. So if I type in x squared equals 25, here's my two x-intercepts at 5 and at negative 5. That's what we just solved for. This is when the function equals 0. Notice the y-coordinates are 0. So we can write this as 5, 0 and negative 5, 0. Those are our two x-intercepts. Let's look at another one. Over on the right, x squared equals negative 16. So if we take the square root of both sides, we end up with x equals the square root of negative 16. This is going to be no real solution. And remember what that looks like. Let's take a look. Is it x squared? It must be really... Why are you not graphing? It's never gonna touch. I'm not sure why it's not coming up. Let's see. Okay. There we go. So this is the graph. It's never going to touch the x-axis. Notice here's the minimum at 16. It's never going below that. So if it's not ever touching the x-axis, we have no solutions. Beautiful. Let's move to slide 5. Try a couple more. Okay, so for the first one on the left, we will subtract 3 on both sides first. Then we get x squared. 3 minus 3 is 0, equals, it was 52 minus 3 is 49. Then we'll take the square root on both sides, and we get x equals square root of 49. Maybe you're not sure. Just type in square root 49, and we get 7. We're going to get into the habit of doing plus or minus 7. So this means the two x-intercepts are at 7 and negative 7. And if you want to see that on the graph, we can always check our answer. So we had x squared plus 3 equals 52. Here we go. And here's our x-intercepts at 7 and -7, just like we got. Let's look at part B. I'm going to draw a little line down the middle. Beautiful. The first thing that we can do is to get rid of this -100. We can add 100 to both sides. We want to start to get x alone. That's our goal when we're solving for x. So then we have 4x squared equals -100 plus 100 cancel, and 0 plus 100 is 100. Then we can divide both sides by 4, and we get x squared equals 100 divided by 4 is 25. Square root of both sides, and we get x equals plus or minus 5. So again, remember what that means? We're solving for x-intercepts. So this is 5, 0 and -5, 0. Get everything you need. Pause the video if you need to. And when you're ready, push ahead to slide 6. We'll look at a few more together. On slide 6, we have x minus 5 in parentheses, all squared. So to get rid of the squaring, we always do our square root. So then we have x minus 5. It gets rid of the squaring. They cancel each other out. The square root of 25 is plus or minus 5. And then we're going to add 5 to both sides. We get x equals 5 plus or minus, 5. So we have two answers here. Our first one is 5 plus 5, which is 10. Our second answer is 5 minus 5, which is 0. So our two solutions are at 10, 0, and 0, 0. Let's graph it, see what it looks like. So we have x minus 5 all squared equals 25. Here's our graph in blue, and here's our intercepts at 0 and at 10. So we can just graph these problems to make sure we did them correctly, which I love. I think that's a great tool to have. Let's look at the one on the right. X plus 6 all squared equals 100. So first thing, to get rid of that squaring, take the square root of both sides. That made my square root really tall. And then we have x plus 6 equals, the square root of 100 is plus or minus 10. Then we'll just subtract 6 on both sides. And we get x equals -6 plus or minus 10. So our two solutions are -6 plus 10, which gets us 4. And -6 minus 10, which gets us -16. Perfect. And again, if you want to check it in the graph, we have x plus 6 squared equals 100. And here we go at 4 and -16. Just like we got. It's perfect. Beautiful. Okay, let's look at slide 7. Approximate each equation. So sometimes we don't have perfect squares, and it's tricky, but we can approximate. If we were to take the square root of both sides for x squared equals 40, we would get x equals plus or minus the square root of 40. Oops, not just 40, square root of 40. That is not a perfect square, so it's going to be a really messy decimal. So I'm going to actually pause the video here before it cuts me off. So come back and check out part 2, and we will keep working on this assignment together. See y'all in a moment.